Hi guys, this is Jared with Datamedics again. In this video I wanted to go ahead and show a demonstration of using Apex Tool Labs read-write head replacement tools. Now Apex Tool Labs is a company, they make these really nice metal E-type and C-type as well as ramp set type read-write head removal and replacement tools. They sent us a few for us to test out and provide feedback, and we've actually really liked their tools. It did scare me at first that they're metal tools, but I'm finding after using them for a little bit they actually do work quite well. There's certainly something I would say is comparable to what you might see from other companies such as HDD Surgery, but these are actually at a much more affordable price. Now this is not intended to be an instructional video for doing your own read-write head replacements. We certainly recommend please leave that to professionals who have proper equipment like PC3000 that's able to stabilize the drives and extract the data safely after read-write head replacement is done. But we're just going to show how these tools are used. Now the first thing you'll see, just monitoring our particle counter. Now as you can see, it finally just reached 0, so that means that the air now inside of this benchtop clean hood is now clean enough that it is safe to open the cover of the hard drive. So we always let the clean hood run for a while, make sure the particle count goes down to 0. When that clean hood is not running, you might see that count up more like 700, 800, 900 parts per cubic foot or per cubic yard. So first step, obviously, we're just going to go ahead and remove all the screws, open the top cover of both drives. Now in this particular case, this was a real data recovery case, and we did use these tools for the case. We've actually already recovered the data when this video is being recorded, so we're actually at this point just putting back the read-write heads into the donor hard drive that they were originally pulled from. So you can see on the hard drive on the right, as we have labeled, is the donor hard drive. So we're going to be taking the read-write heads out of the original, the hard drive that we recovered, putting them back into our donor, retesting those to see if they can be kept for possible use in future cases if we get a very close model hard drive in for recovery. So I won't be talking this entire video, so please enjoy the video. I'll just mention what I'm doing at certain points and talk about the tools and why they're useful. So as you can see, the Apex Tool Lab tools, if you buy the full set, they come in a nice plastic case with each tool sealed in little Ziploc bags. You could probably take those out of the Ziploc bags if you prefer. I like to keep them in just for the sake that it keeps the dust off of the tools, keeps those as clean as possible. The less potential contamination we get into the hard drives, the better. So this way here, if they're sitting in storage while the clean hood is not being run, it's less likely that any dust will actually get onto the tool itself and ultimately end up inside of the hard drive. So it might take a moment of searching through to find the correct family. They are labeled on the back of each plastic bin, so if you look carefully, you might be able to see that. Okay, so I actually picked the wrong tool on the first try. Now, this video is, we're doing the voiceover now afterwards. Trying to record audio while doing this sort of work is not only distracting while performing the work, but also the loud noise from the heavy-duty fan that's blowing through the HEPA filter directly over the work area can be quite distracting and obnoxious to listen to. So, okay, so we went ahead and found the correct tool this time, which is the Western Digital Raider 3-platter E-style tool. So now the first trick is getting the tool in carefully. Now you want to make sure the tool rests on the bottom of the hard drive assembly. So right now I'm just positioning it, making sure everything lines up and it is the correct tool. And first thing I want to do now is get the voice coil ribbon cable and connector out of the way. So now with the tool resting on the bottom, I generally like to just use a pair of tweezers. Once we get it started, make sure it's simply resting on the bottom the whole time. It doesn't get lifted up, and then just a gentle pushing motion. Now you want to pay careful attention to where the tool ultimately goes under the read-write heads. You don't want it under the sliders, but rather you'll notice on this model there's a little hole near the tip there. And I want to aim, as I'm pointing with my tweezers there, I want to aim to line it up about centered with that little hole, which will end up just a little behind the sliders. When I pull the heads out after, I'll show you how the tool is positioned so you can kind of get an idea. And just a little gentle push. As you can see, it lifted the top read-write head, and if the tool was properly positioned, all of the heads should have been lifted either up or down away from the platter surface. So now at this point, the heads are now suspended above the platter in the parking zone, and so now we can remove the magnet and go ahead and remove that headstock assembly. Now with this particular model of hard drive, there's no screw in the bottom holding the headstock assembly in place. Rather, it's just slid over a spindle point. So it's just a matter of getting some forceps in there, getting it positioned at the right angle, and then you can just gently guide it straight up and out. Sometimes it takes a few minutes to find the correct angle. This particular one I found to be a little sticky. It took a little bit of working to get it at just the right angle where it would slide up. But with a little bit of patience and a little bit of careful effort, you can pull it right out. I'll go ahead and show you how those read-write heads there are with the tool positioned under them. And as you can see, the tools hold nicely in place if they're positioned properly. It stays right with the read-write heads. Even if you tilt the tool a little bit, you wouldn't want to turn it with the tool straight down where it might drop out. But with a little bit of care, it easily stays within the tool. So now I'm just going to go ahead and repeat the same process now on our patient hard drive. So the read-write heads that I just took out of the donor were actually the patient hard drive. So those are actually the failed read-write heads. These are now the good ones that I'm going to be taking out of the drive that we recovered and putting back into the donor. So the set of read-write heads that you see set aside, right now that's actually the failed set from the original hard drive. Now one thing I do like about the Apex tools, they do give you 2 of every tool if you order the complete set, which is really nice because as you can see we can leave one in the original read-write heads and then we still have another tool that's identical to use for the patient hard drive, or in this case to remove the read-write heads and put back into the donor. So when you push the tool in under the read-write heads, you want to make sure you're at as much of a perpendicular angle to the angle of the headstock assembly. So as you can see, we're forming kind of a 90-degree angle with the actuator arm, and that's the angle that it will slide in best as you put a little bit of pressure on it. And now you'll notice, so when I remove the magnets, You'll probably see a lot of videos, guys using magnet tools to pull out the magnets, but I found that nothing works quite as well as just a good pair of short pliers with a nice serrated edge to give it a good grip. So that's what I've generally used. I've tried various magnet tools, but to be honest, I found that some either aren't strong enough or they just have other limitations. I've had one break apart while I was using it, so I've really found that nothing works quite as well as just a good pair of pliers for this. So since this is the good set of read-write heads that we're pulling out now, rather than setting it aside, what I'm going to do is to go ahead and just move it directly now into the hard drive that we're going to keep those heads in. So just pushing down on that retaining clip with my tool to get the actuator assembly over that retainer. And then as you bring the read-write heads back to the parking position, you want to be careful. This particular drive has a little magnet that holds it, so as you can see I'm holding with 2 fingers to keep that actuator really steady. I don't want it to bounce as it gets up to that magnet and end up having the tool hit the platter surface or perhaps pop out, because that could result in scratching on the platter. So we just want to be very careful with that. Putting the magnet back in, I find a good way to do that is put a little screwdriver or spudger in there and go ahead and just lower it down slowly like you saw there. Now this is one of the trickier parts. What I'm about to do now is to actually remove the E-tool. If you pull a tool out too quickly, it can have a tendency, I found with many of these tools, to kind of pop out and drop the read-write heads quickly onto the surface. And if you do that, because read-write heads are so sensitive, they very easily are damaged or destroyed by the dropping of the read-write heads onto the platter surface. So when you pull it out, what I find works well is to actually kind of rotate the tool a little bit. So it's not pulling straight out as you would when you put it in. As you can see, I'm going to kind of rotate the tool. Might move the platter a little bit because it is touching on the outer edge. And from that angle there, as you can see, it has a much greater chance to slide out smoothly, lowering the read-write heads gracefully onto the platters. So then just as when we put it in, we want to just gently nudge it. You don't want to grab onto it where you might accidentally lift up on the tool, because that could scratch the underside of the platters. So just gently nudging it until it comes right out, and that's it. So the read-write heads have now been put back into the donor hard drive, where they'll be retested to confirm that they are still viable for potential use in future cases. Provides a clean storage for the read-write heads sealed inside of a hard drive, so that way if we ever need them in the future, we can retest them again at that point, make sure they're still good. So that's about it. So for the next few minutes, you'll notice I'll just be closing up the 2 hard drives, putting the bad heads back into the customer's hard drive so that can be returned to the customer. But yeah, I would just say we really enjoyed the Apex tools. Looking forward to seeing what else they come out with. I know they're starting to develop several C-type tools, the type that is more like the HDD surgery tools, where it actually will hold on the pivot point of the actuator assembly and then rotate in under the read-write heads. The E-tools, though, actually work quite well as long as you have a steady hand, but if you want to put a lower level technician on it, something that perhaps requires a little bit less training, then those tools could be useful. So I'll go ahead and throw a link up on the screen